In this tutorial, we will show how to change the surface of this cube that is melted in a wind tunnel, adding a fillet on this corner. So what we want to do is to add the fillet just on this corner. To do that, we need an auxiliary file that we use as a target. The file is the new desired shape for the face. Here is the STL file containing the desired fillet. To do that, we open a GGNS that is a volume mesh, so that we can see the effect inside the volume as well. And here we can recognize that we have the same arrangement. So we have the cube, the ground, we select the scene shaded mode like this. So I have for this a pre-computed RBF setup, so we open RBF Morph and we reload the STL project file that is already including what we need for this purpose. We can browse the setup. We have here an NCAP. Such an NCAP is aimed to work just around the edge we want to fillet. We have an arrangement also of points to limit the morphing just inside the domain NCAP. Then we have surface points. We have in this case 3 sets. Why we use 3 sets? Because all the faces of the cube are stored in this GGNS file as a unique face. So we want to impose the projecting action on this face and this face separately. To do that, we have selected using an NCAP selection the whole cube here, as you can see, and the associated selection NCAP tell us that we are going to, here we go, we are going to use just the nodes of the cube face that are here. We do the same for the other side, so we add a second set with the cube with the selection NCAP, but in this case you can see that the selection NCAP is here. So this allows to, by finalizing, you can see that we have points here and we have points there that will be updated. Furthermore, we want also to protect, in this case, the ground. If the domain was chosen a little smaller, no other thread should be involved in the morphing. But in this case, we are touching the ground, so we have a third set in which we use the ground, and just the nodes that fall inside the domain NCAP are used, and such points are to be fixed. If we have a look to the set M, we can see that for this thread we have that is fixed. For the second and the first one, we have the same input. That is, we use as an input an STL file. We have here the name of the file. You can see, in this case I used the 20 centimeter fillet. I have a file for the 30 centimeter fillet as well. And you have other parameters. We use the default. The scale factor is if the STL file is with different units with respect to the mesh, and the sampling if you want just to use just a part of the faces that are stored in the STL file. Once we finalize, we can see the effect, because we can see by the preview of the points that the points will be projected onto the STL file. This is true for the first set, and for the second one, to see this better, we can switch off the faces. Here we go, and you can see clearly what is the effect. If we put everything together, we can see that the points that we are controlling will be updated in this new position. We can zoom in to see this closer. Here we go. And you can clearly see the effect of such a projection. Once everything is ready to go, we can go ahead. So we can go into the solve panel. You can collect all the source points all together. You can see the source point and the final position. We can compute the solution. So we start the RPF solution. And once the solution is computed, this is a small mesh, we can directly morph the whole domain. So you can see here the effect. So let's switch on again the faces. This is the final morphing with the fillet, and you can compare this with the undeformed one. Furthermore, you can see how the system is smoothly going from this original position to the undeformed one. So with 0 we have the original shape, with 1 we have the final position. We can also now have a look to what's going on inside the volume mesh. To do that, we go here, we deselect everything but the volume mesh like this, and we select the outline configuration, switch off faces and edges. We can zoom out to see the whole domain, and now we can add a cutting plane. The cutting plane should be positioned like this. We can compute, and if we have a look to the cutting plane, we can see what's happening inside the volume mesh. We can zoom a little bit to see inside the mesh what we have. We can also use elements to see the cut, and if we go back and see the cut like this, we can even in this case see the effect of the morphing. That is a pretty local effect, as you can notice, that is imposed to the surface and is gently propagated to the volume mesh.